Following this module, we will learn about some solution methods available in simulation, conducting different studies for this piece. We will maintain the same charging conditions and restrictions for all analyses, applying different solution methods. In order to identify the maximum voltage generated due to the applied loads. In this class we will create the first study, in which we will use the standard solution method of simulation. The results of this study will be important to compare with the results obtained by the other solution methods that we will study further. Open the available file and let's get started. First, we will simplify this model by removing these rounding that are not relevant to the analysis. Next, we created a new static study, naming it as the standard solution. With the material downloaded from SolidWorks, the next step is to fix the face shown. Next, we will apply force, but first, we will divide the face shown. We set the value to 5000 lbf, and confirm. The next step is the definition of the mesh, but before you do this, let's talk a little about simulation solution methods. For static studies with solid mesh, simulation provides the standard solution method and two additional methods, called H-adaptive and P-adaptive, which we will know in the next classes. In the standard solution method, simulation generates a mesh formed by second-order elements, the characteristic size of which is specified by the letter H, which corresponds to the diameter of a circle circumscribed in a triangle. These elements are commonly called H-elements due to this characteristic. The size of these elements is set automatically, based on the surface area and the volume of the model. We generate the mesh, and look at the elements created for the model. We run the analysis. We note that the maximum voltage of von Mises is below the flow voltage of the material, and that it occurs in the vicinity of the curvature of the model. We completed this lesson, where we created a study using the standard solution method of SolidWorks. Do not miss the next class, where we will continue learning about the method of H-adaptive solution.